Hi, my name is Izzy, and today I'll be walking you through how to do problem number 2 from the 2013 FRQ of the AP Calculus BC exam. So here's the question. It gives you two polar curves, r equals 3 and r equals 4 minus 2 sine theta, and it tells you that they intersect at theta equals pi over 6 and theta equals 5 pi over 6. So let's start with question A. Let S be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 4 minus 2 sine theta. Find the area of S. So to start off, I labeled the intersection angles, and you can see that underneath that is 2/3 of a circle. So you could find the area of that first and then find the area of this sliver. A common mistake would be to try and just subtract an area of the circle from the area of the limacon or vice versa, but that doesn't work in this case because that would only work if it's the area inside one curve and outside of another. This is not that problem, although those problems are very common as well on your test quizzes and homeworks. So again, we're going to be finding 2/3 of that circle first. So here's the work for that. So the radius of the circle is 3, so you're going to have the area of the circle is 9 pi, and then you want 2/3 of that, so that's 6 pi. And then to find the area of this little section, I use the formula for area of polar curves, which is 1/2 times the integral from a to b of r squared. And they gave you the bounds because they told you where the curves intersect, and the section that we're trying to find is in between them. So your bounds are just pi 6 and 5 pi 6. And then for r, you're going to plug in 4 minus 2 sine theta, because if you plugged in 3, you'd also be adding in this white part right here, which you don't want. You just want the part under the limacon. And then this is a calculator problem, so you would just plug into your calculator and find how to do it. So here it is. I'll do it for you. So I'm going to find the integral first. So to find an integral, you're going to go to math and then scroll down. It's number 9. And then you're going to enter your bounds, pi over 6, 5 pi over 6. And then put a parentheses. Even though it gives you parentheses, you want another one because later you want to square the whole function. Make sure you keep track of your parentheses, because if they're in the wrong place, your calculator may not compute the function. And then your d theta, enter. And then remember there is a 1/2 out front, so you're going to have to divide that answer that you just got by 2. And then you're going to add in the 6 pi. And you get 24.7087, so that can be rounded to 24.709, or you can truncate and leave it as 24.708. College Board accepts the answer either way. And for this problem, you get a point for the integrand, a point for the limits and constant, and a point for the answer. So if you're really grasping for points and you don't know how to do it, I would just say try and write out this area equation. Maybe you could get a point for having the right bounds and the 1/2 out front. And for problem B, it says a particle moves along the polar curve r equals 4 minus 2 sine theta, so that at time t seconds, theta equals t squared. Find the time t in the interval from 1 to 2 for which the x-coordinate of the particle's position is -1. So for this problem, you need to know that x equals r cosine theta. That's something that should be memorized, as well as y equals r sine theta. So you're going to plug in your r, and at this point we're just looking at the limacon, we're not looking at the circle. So your r is 4 minus 2 sine theta. And then it told you that theta equals t squared, so you're going to plug in t squared anywhere you have a theta. And then you're going to set that equal to -1, because you're trying to find t when the x-coordinate of the particle's position is at -1. And then to find it, I moved 1 to the other side by adding 1. And now you have a function that's set equal to 0, so if you graph it on your graphing calculator, you can find the 0, and that's how I solved, so I'll show you. So you go to y equals, and you plug in this function right here. And then graph. And my calculator is in function mode. If it's in polar mode, you won't be able to find zeros, so just make sure you check the mode of your calculator when you start working. And then once you have your graph, you're going to go second, calc, and then go to number 2. That will help you find zeros, and it told you it was between 1 and 2, so you're going to set your bounds near there. So set a left bound and a right bound, and then set a guess. And then it tells you that x equals 1.4279793, and you can round to 1.428 like I did, or you can truncate and leave it as 1.427. You would get points either way. And for this problem, you would get a point for the plugged in r cosine theta, so this one. Or if you already knew the format and you just went straight to the t-squared version, it's the same point. And then if you set it equal to -1, you get a point, and you get a point for the answer. So if you don't know how to do it, at least try and write out the r cosine with the plugged in 4 minus 2 sine theta. You could get some points for that. So for the last question, it says, for the particle described in part B, find the position vector in terms of t, find the velocity vector at time t equals 1.5. So for here, you already found the position function for x in part B, so now you just need to find the one for y. Y equals r sine theta, so you're going to plug in the same r, 4 minus 2 sine theta, and then again substitute in the t squared for all the thetas. And then so your position vector is the brackets, and then 4 minus 2 sine of t squared times cosine of t squared, comma, 4 minus 2 sine of t squared times sine of t squared. So that's your position vector. And then to find the velocity vector at t equals 1.5, velocity is the derivative of position, so you're just going to find the derivative of the position function at those values. And if you labeled them above, you could just write it like this. You don't need to write out the full thing, because this is the calculator section, and then you're just going to type it into your calculator. So to find a derivative, you're going to go to math, and then scroll down, it's number 8. And then do your function, your variables, and then type in your function. So first we're going to do the x one. Again, make sure to keep track of your parentheses. And then it's going to ask you where you want to evaluate, so that's going to be your 1.5. So you get negative 8.072. You cannot round up because the next value is 1, so you just leave it as negative 8.702 or 0.72. And then next you're going to find the y1, so you're going to go to math, derivative, put in your variable, put in your function. This time we're looking at the y function. Again, evaluating at 1.5. And then you get negative 1.6729, and you can round up to negative 1.673, or you can truncate and leave it as negative 1.672. So for this problem, you get 2 points for the position vector and 1 point for the velocity vector. So there's really no partial credit. You just have to know that r equals cosine theta from the last problem, y equals r sine theta, and then you plug in your t squareds, and then that would give you the position one, and then you knowing how to use your calculator would really give you the last point for the velocity vector. So that's how you do problem number 2 from the 2013 FRQ. I hope this was helpful, and if you need more resources, I will link some problems down below. Thank you for watching, and good luck on your AP tests!